In this video, we are going to talk about strings and characters. This video has no prerequisites. As you can see, I've started off with a program. I call it Characters and Strings. Okay, be sure we include IOStream, and we're including another library. We're including the string library. That's to allow us to work with strings. Once we include the string library, we have, in effect, included a bunch of functions or library books we can check out and use in our program here. So I defined a character as a character, and I've initialized it to A. I've defined a string called a string, and I've initialized it to A. Notice the character is enclosed by single tick marks. The string is enclosed by double tick marks. These two variables are different. They are not the same. They are stored differently in the computer. You could see I have a red squiggle here. All I wanted to do was check to see if the character equals the string. And I have a print statement here. So what did I do wrong? So characters can only store a single character. Strings can store many characters. You can consider a string as being a letter stored in a shoebox. So if we have the string car in shoebox sub 0, or in the first shoebox, we have the letter C. In the second shoebox, we have the letter A. And in the third shoebox, we have the letter R. Note here that I started the first character at location 0. C++, C, and most programming languages, if not all programming languages, will start at 0. This is key to remember. So when we have a string, and the string is initialized to car, the first character position is 0, the second character position is 1, and the third character position is 2. So when we are comparing a character to a string, it makes no sense to the compiler. We've got to compare a character to just one character of the string. The way we can fix this is by specifying location 0. Now the squiggly line goes away, so I'm comparing a character with the first character of string. Let's run this and see if everything works. Okay, the character A is equivalent to the string A. Let's look at this a little more closely. I've done something here I want to show you. I also have a little problem here. I need another tick mark after the A. So I'm printing out a bunch of characters here. I'm printing out a string, then I'm printing out the value of a character, and I must include a single tick mark to go around it. I have another string, but if you notice right here, I have a backslash and a quote. You can see I have the backslash and the quote over here too. We need the backslash in this case to signify that I want to print out a double quote. If I did not have this backslash, the closing double quote would be the first quote here. So let's run this and see if it works. See, it's saying I have an error now. It's telling me right here on this line there is an error. That's because the compiler is getting confused because I have too many quotes here and it doesn't know how to resolve them. I need to put my backslash back in here. Now, when I see a quote, double quote, I want to look for another double quote. So as it scans this string of characters, it looks for the following double quote. It sees I have a backslash double quote, and it says anything following a backslash, treat it as a character. Don't treat this double quote as a matching double quote for right here. So I see a double quote, I scan these characters, I see a backslash, I continue on, and I finally see the last double quote. So that's why we need a backslash in front of the double quote. Otherwise, if we did not have the backslash there, we would get confused, or the compiler would get confused. Let's run this program again. And the character A is equivalent to the string A. Okay, the contents of the string, not really the string, but the contents of the string. Let's clarify this. Contents of the string. The contents of the string is solely the letter A. If you're an old-timer like me, you will know that you didn't have strings in the language C, which came before C++. All I had was character arrays to work with. Now, character arrays are similar to strings in that they all have these shoeboxes, and each shoebox can store one character, but they're a little bit different, and they are not stored the same way in memory. So if we have the string hello, we have 5 shoeboxes. The first shoebox is H, the second is E, the third and fourth both contain L, and the fifth is O. Now, character strings have a special character at the end of the string. It's known as Backslash Zero. Every character string has a size, the shoeboxes. So in this case, our string is 5 characters, but we need an additional character to store the Backslash Zero. So our character string in this example needs to be 6 characters in length. When we define our character string, we specify it as is written on line 15. However, we will associate a size with the character string. So a character will have 6 shoeboxes or 6 locations. And like I've said earlier, each character is enclosed by single tick marks. Now here we specify the size. Right now our size is 6, so it's open bracket, open square bracket. We put the size in the character array, and it's 6. So that will include hello and the backslash 0. Longer strings would not fit in this a character string. Now we're going to initialize it down below. We will not pre-initialize it or set its initial value. To set a string to a string, all we have to do is type hello. That is the string hello. Characters are a lot more difficult, so be thankful that you're not working in the language C. So we have to initialize each character individually. And the way we do that is by specifying a character and the shoebox that we want the character to be assigned to. So in the case of the H, we want a character sub 0, and that's how we speak to the 0th character is H. And a character sub 1 would be E. And I'm just going to copy this 6 times and modify the indices. The indices are what's between the brackets. So we're going to go from 1, 2, 3, 4, 5. E, L, L, O, and the special character backslash 0. Even though backslash 0 takes up 2 locations in this case, it is considered 1 character. So once the compiler gets to line 22 or past line 21, we have a character string called a character, and it stores the word hello. Now again, since we have a character array, a better name for this would be a character array. So I'm going to change that now to be a character array. I'll just use the search and replace, and I'll search for a character and replace every occurrence I find a character with a character array. I missed a couple. Let me hide these and search again, and I replaced a character with a character array. Now to effectively compare a character array to a string, we'd have to do all 5 characters. I don't have time to do all 5 characters or code all 5 characters, but this compares the first character of char array 0 with the first character of a string. So that gets the first character in the character array, and the first character in the string is also sub 0. So a character sub 0 is equivalent to a string sub 0. Let's run this and verify that H is equivalent to H. Finally, let's talk about some functions that we could perform on strings or characters and character arrays. I have modified the program a little more, and if we start at line 23, I've modified a string to be hello to the world. If we look at how hello to the world is stored in a string, we see that it starts with index 0 with an H, and we can follow it through. So a string sub 13 is D. So we have some character functions, and these are holdovers from the C language. So the C language did give C++ some things to use. We can check if a character is a digit or not. That's what we're doing here. I'm setting a Boolean value to whether a string sub 7 is a digit. Here I ask whether a string sub 5 is a digit, and print the output. And then we could do some interesting things like this. A string currently is hello to the world, and the W is capitalized. That's the only capital letter in the string. With to upper, I'm going to change the H from a lowercase to an uppercase. That's what I'm showing here. So those are character functions, and these are not all the character functions. Let me show you how to search for functions. If we open up a window, we could search for C character functions. Look at that. What comes up first? C++ again is a very good reference. If we click this, we can see all the functions for characters. We have is alpha numeric, is alpha, is space, is digit, right here, is blank. We have to upper and to lower. Now we also have some string functions that strings of C++ give us. So let's change this character to strings. And again, we get C++. So let's open this up right here and see where it brings us. Talks about strings, and here are all the functions we can do with a string. I'm printing out the size of the string, which is the length. I'm finding out where the string world exists, and I'm creating a new string called new string, which is just a substring of a string. So let's run through this program. So here are the character functions. H is not a digit, that's a true statement. 2 is a digit, not a true statement. A string contents before the change. This is when I'm changing the H to uppercase. A string contents after the change. Hello is now capitalized. The size of the string is 14. If we look at what we have here, we go from 0 to 13. That is 14 characters. Now if we look for where world starts, world can be found in a string starting at location -1. That doesn't make sense. What did we do here? Okay, we are checking for the string lowercase world, or not capitalized, but we capitalized the W. So -1 is signifying that it's not found. -1 usually signifies that something wasn't found or we have some kind of error. It couldn't return a valid answer. Let's change our program here a little. Let's change this to an uppercase W. And now let's run this program again. Okay, we looked here. World. I want to change something here to make it consistent. Let's change this to uppercase W. And now let's run our program. So we can see that world can be found in a string starting at location 9. So this is the 9th location, starting from location or index 0. And we're going to create a new string, which is just a portion of a string. Okay, a string or new string is now world. If we look at the command to create that, it's substring. Substring 9, that's the starting location to grab, and the next 5 characters. So we're saying grab from location 9 all the way to location 13. Anyway, these are string functions and character functions. This concludes the video on characters and strings.